Let's talk about solving linear equations. If I go too fast, tell me to slow down. I get excited sometimes and start talking fast. All right, so what is a linear equation? Get x by itself. It's got an x in it, right? So maybe it looks something like, we'll start out easy. Something like this. I got to figure out what x is. I got to get x by itself. I got to isolate it. How do you know what to do to get x by itself?
By both sides?
You're close, but you're backwards. You're good, exactly. A lot of you, and I'm going to show you this order because a lot of you have had teachers that have just said get the x by itself, work outside in. But really, whenever your equations start getting complicated, like they're going to get in this class, you need to know the order to do stuff. So a lot of you have done PEMDAS before. That's when we simplify things, okay? But solving is the backwards of simplifying because we're undoing. So we need to go in the backwards order. So we're going to go SADMAP, okay? So the first thing I want to do is I want to look for any addition or subtraction. So I have some addition, and several of you have said that already. I'm adding 1, right? So I need to think to undo addition, what do I use? Subtraction. So to get rid of 1, I subtract 1, right? But because it's an equation and it's balanced, if I do it on one side, I have to do it to the other. Are we all? I can take it slower, breaking down a little bit more, but most of you, are you following me? Okay. This is gone.
Awesome.
Do what? So it's going to be 2x equals 8. Yes. So next up, I've done addition, subtraction. Next up, multiplication, division. Right? So because this is being multiplied, the opposite of multiplication is division. And so some of you are saying divide, and you're absolutely right. I divide by 2. It's going to be 4. Easy? You sure? Okay. What if... Y'all got that? What if I added, actually, let me say 2/3 x. Oh, somebody said, equals 4. What in the world do I do now?
You're going to make 4 into a fraction. You're going to take 4 over 1, and then you're going to do the
You're close. You're very close. Here's something I want you, and I'll probably say this 1,001 times during the course here. When you are multiplying by a fraction, we never want to divide by a fraction, even though the opposite of multiplication is division. When we're talking about fractions, instead we multiply by the reciprocal. That's a big word. What's reciprocal mean? Somebody said it. Flip it. Now before I actually do it, I'm going to give you a second to. So, I got 2/3 times x. What do I do? Flip it. 3 over 2. 3 over 2. And we did put this 4 over 1 because I need, whenever I multiply, I want to make sure it's in a fraction form, okay? Reciprocals, when multiplied, cancel each other out. How do you multiply fractions? Well, it's not, when you say cross, what we do, we go straight across, not crisscross, okay? Top times top and bottom times bottom. So 4 times 3 is 12. And 1 times 2 is? So what does x equal? Don't get intimidated by fractions. No? Yes? Maybe so? Kind of. Actually, we just said when we multiply fractions, and I'm just kind of trying to fill in some holes when I see some faces as I write things. When we multiply fractions, that's top times top over bottom times bottom. We just multiply straight across. But what if I had to add or subtract fractions? It's a little bit harder. Why? Exactly. You got to have like denominators. Do y'all remember how to do this, or do I need to sidetrack and take some time to show you? Y'all talk to me. If y'all are good, I'm not going to waste the time, but it could pop up on your test.
Show it.
Show it. Okay. I'm going to go to a clean page. All right. So when we add or subtract fractions, we have to have what we call a common denominator. So maybe I have 1/3 plus 2/5. I can't add those like they are because the bottoms aren't the same, right? So I need to force them to be the same. So we start talking about least common multiples. Remember that? 15. The smallest number, if you start listing everything, 3 times 1 is 3, times 2 is 6, times 3 is 9, and do the same thing for 5. The smallest one they have in common, and y'all said 15. What do you need to multiply 3 by to get 15? 5. So I do it to the top and the bottom. What do you need to multiply 5 by to get 15? 3. So the first fraction becomes 5 over 15, and the second fraction becomes 6 over 15. Once the denominators are the same, exactly, denominators are the same, we combine only the tops, the numerators. I'll give you a second to copy that. All right, so looking at the tops, 5 and 6, that gives me what? 11? And you keep that denominator. Don't add that, you keep it. Okay, so you combine the numerators, leave the denominator. Does that make sense to everybody? Remember now? Is it coming back to you? A little bit? Okay. So I showed you this because some of our equations are going to have fractions in them as we're going through solving, and you're going to need to know how to do that. Now your calculator, I know a lot of you don't have your calculators yet, but your calculator will do this for you. Does anybody have their calculator yet? A couple of you? Okay. I'll show you real quick. 1/3 and 2/5. Come on. Your calculator will add and subtract fractions for you. It's very handy. You don't have to go through finding common denominators. You always put fractions in parentheses. So if you do 1/3 plus 2 divided by 5, that's a decimal, but I want a fraction, right? Right? So if you hit math, see that very first option says fraction? If you hit enter, it gives it to you as a fraction. So you don't have to go through finding a common denominator. It makes adding and subtracting fractions very easy. Okay, so if you got it, you can start using that by all means. If you don't, you'll have to add and subtract them by hand, unfortunately, right now. All right, let's do another solving. Let's do this one. Same two-step equation. The difference now is I had some fractions thrown in here. I'm going to write my SAD map off on the side. What do I do first? You're going to add 1/3, exactly. Because I'm doing my addition subtraction first. So I've got 4/1 plus 1/3. 3, need to multiply by 3 because that's my least common denominator. If you have your calculator, you certainly may do this on your calculator. 13/3? Yes? No? Maybe so? Am I going too fast? Okay, I'll slow up just a second. All right, so we've got on this side 13/3. 2/5 x over here. X is still not by itself. What do I do? Multiply by the reciprocal. I don't want to divide by 2/5 because that would give me a fraction and a fraction. So instead, flip and multiply. So remember, multiplying fractions is easy because it's straight across. 13 times 5, 65 over 6. Done. Easy? All right. Recognize the equations that we've been doing so far have x written only one time. If you see only one x in the equation ever, you can always SAD map your way out of it, even if there are parentheses in the equation. For instance, let's say I have this, okay? A lot of you might want to distribute that side first. To me, that's a lot of work, and that's more work is more room for careless mistakes, right? So when you only see, and I'm going to make a note here so you have that, when there is only one x, and we're going to do some that have more than one x, okay? But when there is only one x, don't simplify. Just SAD map. Map this. Notice in SAD map the very last thing is what? Parentheses, right? That's the very last thing I'm going to do. So anything inside here I need to hold off till last. So looking outside parentheses, is there anything I can take care of? Divide by 3. This 3 is implied multiplication here. There's no sign, but I'm going to imply that that's multiplication. So I can divide both sides by 3. Now my 3 is gone. Yes? Okay. Now can you get x by itself? Sure, that's easy now. What do you do? Plus 1. Is anybody confused so far? Am I losing anybody? I hope this is a review for most of you. I hope it's super easy for you. Let's set up a scenario. What if you see more than one x in your equation? So maybe it's 5x plus 7 equals 2x minus 3. I can't just start SAD mapping because there's 2 x's. So what do I need to do? Get the x's together. This pen just randomly quits working sometimes. All right, so which x should we move? Why the 2? Because it's smaller, exactly. Somebody taught y'all right. Get the x's together. So I'm going to put here, move the smallest. So move the 2x. To move the 2x, I need to do what? How do I move it? Subtract, right? Subtract it out. It can only be subtracted with the 5x because they need to be like terms, so it goes with the x. What's 5x minus 2x? 3x plus 7. The 2x's are gone here, so now I've got that negative 3. Confused? Good? Okay. All right. Now I'm back to an equation with 1x. So what do? SAD map. Subtract 7 first. Exactly. Once you get to the point again where there's only 1x, I go back to the SAD map every single time. Okay. So subtract 7. Now what? Divide by 3. And I'm going to leave it just like that. There's nothing wrong with that answer at all. It's an improper fraction, but that's better than a decimal for sure. How you feel so far? Good? Good. Let's crank it up just a little bit then. You know, that's what we do in math. Let's say I have Can I SAD map this one? No, not yet, because why? I got more than 1x. So I am going to have to work through this and start moving some things around. I can't just move an x right now. Why? Those numbers out front. I can't move something inside a parentheses. So before I start, what do I need to do? Distribute. Y'all love to distribute. So on the left, I get 3x minus 6 equals 20 plus 5x. Am I ready to SAD map? Close. I got to get the x's together. Which one should I move? The 3x, because it's smaller. It's the smallest one, right? All right, so minus 3x, minus 3x. These are gone. The left side becomes negative 6. Am I going too fast? Okay. Am I ready to SAD map now? Yes, because there is 1x. All right, so SAD map, what do I do first? Subtract 20, absolutely. Left side? Negative 26. Right side? Y'all got this. Divide by 2. Make sure you have that one written down because that's actually one from your assignment today. What happens if I start solving something like this? So let's go through. What would I do first? I would distribute here because I have more than 1x. So I get 2x minus 1 equals. Now what do I do? Some of you are already seeing the problem. I got to get the x's together. So I need to move them, but what happens when you move it? Either when I move, that's 0. That's 0. Can negative 1 ever be 10? No. So this equation has no solutions. Which can happen? Does that make sense to you? If your x's cancel out, it's no solution. There is not a single number you could plug in for x there to make that work. Y'all good? Let's apply a little bit then. Let's say, I'm almost done, I promise I am. I don't like to stay up here teaching too long because then I start losing you. Let's say I have a triangle. A wonky triangle. This is probably going to come out so terribly, but we're going to try anyway. Let's say that I give you this triangle with these 3 side lengths, okay? And I tell you that the perimeter, what does perimeter mean first of all? Around. All the sides added together, right? The perimeter of this triangle, let's see. Let's say the perimeter is 42. And then I said, what's the length of each side of the triangle? I got to solve for x, and then I'm going to have to actually plug that x in for all of them. Okay? So let's set up our equation first. Perimeter means add everything together, yes? Okay? So I got a half x plus 6 plus Does that make sense so far? Now I've got more than one x, so I need to do something to get some stuff together. Okay, so what goes together? 1/2 x, 1x, and 3x, and then 6, 5, and negative 12. All right, so let's look at the x's. 1/2, 1, and 3. What's that give you? 4.5, and 4.5 I'm going to put as a fraction. What's 4.5 as a fraction? Y'all remember doing this? 4 and 1/2. You go around the world, you multiply, you add. So 4 times 2 is 8, plus 1 is 9 over 2. Y'all never did that? When you were younger? Maybe you just don't remember. All right, so I got 9. Again, you could put this on your calculator. And then 6 plus 5 minus 12 is what? 1. Negative 1. I'm sorry, I made these numbers up off the top of my head. I hope they're going to, I think they're going to be kind of terrible to work with. All right, so to solve, I need to do what first? I'm ready to SAD map, so I'm going to add 1. Now what? Okay, and how do I get rid of that 9 over 2? Times 2 over 9. So I get 43 times 2, 86 over 9. Does that make sense? I want to make sure you got all the tools to solve the problems you have.
Are you talking about the quiz or the worksheet?
The worksheet, just the review sheet for today. How do you calculate tax? If you go to Walmart and they ring up your stuff and before tax or anything you spent $25. How do you calculate tax on that? How do you know what your bill's going to be if you were calculating it? 7 cents on a dollar. So how could you set that up here? What could you multiply by? Close. 0.07, right? 0.07. So if I multiply by 0.07, that tells me how much tax. But I would then have to take that and add it back, right? So what you can do is you can take your total and you can times it by 1.07 and that adds it back in for you. Okay? Total with tax. Does that make sense? What about, and write these down because you've got some word problems on here and I'm using some different numbers, but I'm setting the problems up for you, okay? So you'll have some examples. What if you get a job and at that job you make $12 an hour, but overtime kicks in, okay? So this is if you work 40 hours. So if it's time and a half, what is that? $18 an hour. Overtime. How could you set up an equation to know how many hours overtime you'd have to work to make, it's 4,480, let's say $1,000 that week. That's a lot, but I know, but I'm just saying, just throwing a random number out there. Well, you know that you're going to make how much in the week? 12 times 40, right? Because you're going to work 40. If you're working overtime, you're definitely going to work for 40 hours. So $12 an hour times 40 hours plus $18 an hour. This is where my variable is because I want to know how many hours I need to work in order to make 1,000. And now can you solve that for X? Okay? I just want to make sure you can set these up because that's the hardest part about these problems is actually setting them up. I think you should be good from here. The rest kind of does the same kind of thing. All right.